If you add up every angle, there are 180 degrees in a triangle. Skateboard ramps are your scene, with 3 different sides, they're called scalene. That triangle would also be called right if a 90-degree angle is inside. If you add up every angle, there are 180 degrees in a triangle.
Well, welcome to another lesson in geometry for 5.4 in our Big Ideas curriculum. We're looking here in Chapter 5 at triangles mainly. We've been talking about different types of triangles, and in this one we're looking at equilateral and isosceles triangles. So we have, even on that video, is just showing us the scalene triangle, and that's where all the sides are different. Equilateral and isosceles triangles are 2 other triangles, where isosceles where you have 2 equal sides, and equilaterals where you have all 3 equal sides. So we're going to be looking at a couple of theorems with the base angles theorem, and also using isosceles and equilateral triangles. First, let's check out a little cartoon for our day. So this one says, snail's on top of a turtle here. It says, whoa, easy on the warp speed there, Zulu. Yes, if you don't remember who Sulu is, that was from Star Trek. He was like, I guess, the pilot or something like that that piloted the Enterprise through space. So obviously the snail's saying, the turtle's going too fast for the snail. All right, let's get into our lesson now for our vocabulary on page 140. So we see these 4 vocabulary words on 140. You want to go ahead and just copy them down. You can even do this, draw out this triangle and then label everything, and that's pretty much what it is. But here you have it. It says a triangle is isosceles, and this is using the base angles theorem, which we will get to in a minute. But a triangle is isosceles when it has at least 2 congruent sides. So that we already learned in 5.1. But here we say when an isosceles triangle has exactly 2 congruent sides, these 2 sides are the legs. So the 2 congruent sides. So what are the legs? The legs are the 2 congruent sides. That's what the legs are of an isosceles triangle. They're the 2 congruent sides. You call those the legs. It says the angle formed by the legs is the vertex angle. And so that's up here, you can see. So you have your angle formed by those 2 legs is up here in the blue. So that's what we could say there. So vertex angle is the angle formed by the legs of this isosceles triangle. And then as far as the base, so what is the base? The base is the 3rd side. So this is our 3rd side. So these 2 are the legs, and then the base is the 3rd side. So base here is the 3rd side of an isosceles triangle. So you've got to realize all of these are going with isosceles triangle. So you want to make sure you realize that a triangle is isosceles here. So that is the main part of these vocabulary words. They're all connected to the isosceles triangle, not the scalene, not even the equilateral for that matter, because they're all congruent sides. You have 2 congruent sides, those are your legs. The 3rd is the base. The angle in between the 2 congruent sides is called the vertex angle, and then the base angles are the 2 adjacent to the base. So these 2 down below here that are adjacent here at the base, those are your base angles. So the base angles here are the 2 adjacent angles to the base. 2 angles adjacent to the base, that's the ones down here. So definitely that triangle, or actually I would draw this picture right there next to your vocabulary. That would be very helpful. Alright, so also on 140 you see the theorems there. So you got the base angles theorem and then the converse to the base angles theorem. And so basically all this base angles theorem says is as if 2 sides of a triangle are congruent, that's right here, so it's isosceles if that's true, then the angles opposite them are congruent. So basically in an isosceles triangle, when you have the 2 sides congruent, your base angles are going to be congruent. So angle B and angle C are congruent. The converse would be like, again, like the reverse. We learned that word in chapter 2. Converse is like the reverse of that. So the converse of this would be, okay, well now if we know that the 2 base angles here are congruent, then we can conclude that these 2 sides here are congruent. So that's what we can say. If two angles of the triangle are congruent, then the sides opposite them are congruent. So the side opposite this base angle would be here for AC, the side opposite this one here, AB. So those two are the two congruent. AB is congruent to AC. So that's what our theorems here are talking about, and then we can go and apply them now. So here's this one. You can just watch this one. You don't need to copy anything down. It says in triangle DEF that side DE is congruent to side DF. So here you can see the marks. So you have an isosceles triangle. It says name two congruent angles. So the base angles, according to the base angles theorem, F and E would need to be congruent. So E is congruent to F based on that base angles theorem. That's how we can apply it. Okay, so on this one, we're going to just again watch this one because we're going to do the first four on our extra practice are going to be like these. So it says if HG, side HG is congruent to side HK, then what angles are congruent? So you can say, well, which ones are HG? So that's this one here. If HG and HK are congruent, that's these two, which angles are congruent? Well, that means an angle G and angle K right here would have to be congruent. And actually, it would probably be better to name it. Since angle K could also be over here, we should name it as angle HGK can be congruent to HKG. So that's what we could say there. And then, so that's that one there, HGK and HKG, like I just said. So if these two angles are congruent, KHJ, so which one's that? KHJ, so that's this guy right here. So this one at the top here is congruent to KJH. That's the other one over here. So basically these two here are showing that they're congruent. So it says then what two sides can be congruent? What then can be congruent? The sides here can be congruent. So opposite here would be this side of HK. Opposite of this one would be JK. So we can KH or KJ. So I did it the other way around. That's fine. I could have named it as HK and JK. That would be fine. They named it the other way around. That's okay. All right, so on page 141, the extra practice starts here with 1 through 4, and you're just going to do what we were just looking at with completing these statements. Looking at this diagram, complete each statement 1 through 4. So I'll give you a chance to try to do that, see if you can complete these correctly. And again, the way you name them can be a little bit different than the way I might name them, and you still might be correct. So go ahead and pause the video and do 1 through 4, complete the statements, and then play it, and just let's check our answers then. All right, so hopefully you've got the answers for 1 through 4, and let's just go ahead and check them. So first of all, number 1, it says you have some sides that are congruent. So that's these sides on the diagram. I'm just going to mark them off here so we can see it on the diagram. JN and MN or NM or NJ. So you can call this JN or you can call it NJ. We learned that also in first chapter. You can go either way. So those two are congruent. If those two are congruent, which angles are congruent? So that's from this big triangle here. So that means that these two angles are going to be congruent here, M and J. So we can actually call that angle M and angle J because that's all there is there on that one. But we might want to also just name it with 3 letters. If you named it as M and J, that's fine. But another way to name them is with the 3 letters. We can call it NJM. So NJM, and then this one would be NM and J. Number 2, we got another couple sides here congruent. So it's these sides here. So we have this one here with LM and this one here with LN. So now we're looking at this triangle right here. If these two sides, what two angles are congruent? So again, because of the base angles theorem, we have this M and this one here. So this is probably why it's best not to keep calling it M, perhaps, because we can't just call this one N. So we're going to need to name this one as LMN. So LMN, that is the way to name that one. And then naming this one over here, we'll name it as LNM. So LN and then M going this direction, where N is definitely the one that's in the middle. Number 3, we got a couple angles here that are showing us congruence. So we can show that these angles are congruent here. Oops, I put the sides on there too quickly. These are the angles that are showing congruence, sorry. So there's the angle showing congruence. We got NKM. That's this guy right here where K's in the middle. NKM. And then we have NMK, where N's in the middle. So we keep using this angle over here. So NM and K. If those two angles, we're looking at this triangle now here. If those ones are congruent, what sides can be congruent? That's why I marked these off here with the 2. So that this side here, MN and KN right there, we could name them back and forth. You could say MN or NM is fine. And this would be KN or even NK would be fine. And then for number 4, another couple angles here showing congruence. So these angles are showing us that they're congruent. So LJN, oops, go back there. So we have LJN, so L is where? Here. LJN, so it would be this angle here at J. And LNJ, so LNJ, we're looking at this triangle again right here. So which sides can be congruent because of the converse theorem of that base angle? So if our base angles are congruent here of this triangle, then that means that this side here can be congruent to this side, LJ and LN. So right there, LN is congruent to LJ. Okay, so go ahead and make sure you checked your answers. If you made any mistakes, just go ahead and fix them. And let's move on to our next part. All right, so here's a little joke of the day. It says it's not really anything to reveal, but we'll just read through it. A mom texts, "Hi son, what does IDK, LY, and TTYL mean?" He texts back, "I don't know. Love you, and talk to you later." The mom texts him, "It's okay, don't worry about it. I'll ask your sister. Love you too." So she doesn't realize that he's telling her what they mean, and so she thinks she has to go ask the sister, because she might know. All right. So on page 141, we see some corollaries. So now we're looking at the equilateral triangle. As you can see on the diagram, all sides are equal, all angles are equal as well. So basically the corollary to the base angles theorem is this: if a triangle is equilateral, then it is equal angular. I even mentioned that maybe at the beginning, that those always will go together. As you're kind of trying to name triangles, if you're going to name it equilateral, it's going to be named equal angular as well, or equal angular is the same as equilateral, as it says on the second one here. So back or forth, if it's equal angular, it's also equilateral. And if we wanted to figure out, okay, what would those angle measures be? In an equilateral triangle, they're always going to be 60, so you can write those in there so you have them. So in an equilateral triangle, since all the angles have to add up to 180, we know they have to add up, each angle has to be exactly 60 degrees. That would be 180 divided by 3 would be each angle being 60, and they'll have to be exactly the same. Okay, so on page 142, we see our extra practice number 5 and 6. Just says find the value of x, and these should go pretty quickly. They have equal angular triangle on number 5, so we're going to just apply that. If it's equal angular, then it is equilateral, and we are told that one side is 31, which means all sides are 31, so we know that x has to be 31, just as a conclusion there. So that was pretty simple right there, just to know that it's equal angular, it is equilateral. All the sides will be the same. This would be a 31 as well. Number 6, we are shown all the sides are 12, so we could see that it's an equilateral triangle. All the sides are exactly congruent. They're all 12. So it is also equal angular. We're trying to figure out what the value of x is, and we talked about what each angle is. If it's equal angular, that means every angle in here is 60 degrees. So angle Z is 60 degrees where it says 2x, so 2x is equal to 60. And then you can just divide by 2, so x would be 30. So fairly simple ones there to do with the equal angular and equilateral triangles. All right, so here's one. You can just watch this one, and you don't need to write this one down at all. Just as we're going to find the value of x and y. And so if we were to, look at our diagram here, we could see we definitely have an equal angular triangle right up here, which means all the sides would be the same. That definitely tells us what y is. If this is 4, then this side's 4 as well, so is the one here. This has got to be 4 as well. So y has got to be 4, and if this side is 4, that's going to go for this triangle also here. We have our base angles are congruent. These two are congruent, which means the sides here we can conclude from that converse of the base angles theorem If your base angles are congruent, then your sides opposite them are congruent here. So 4 is equal to x plus 1, which just means that the x has to be 3, because 3 plus 1 would be 4. So that's what we would see here. Y is equal to 4, and so then that means that if you did that, x is equal to 3. Alright, so here to finish up the extra practice now, number 7 and 8, we're looking to find the value of x and y. So we have our diagrams here, and so you can see what you need to see first of all is what kind of triangles you have in our diagram. We have an equilateral triangle right here on this side, and here you have base angles are congruent on this triangle, which tells you that you have an isosceles triangle up here. You can say that this side is congruent to this side here as well. There's your isosceles triangle. We also have a right angle here, so we know that's 90 degrees. And so what we can also conclude from that is if this is equilateral, that's equal angular, which means all the angles inside of this triangle are 60. So that means that this angle right here is got to be 60 degrees. So if this is 60, this side over here has to be 30, because this is 90 together. 90 to minus the 60 would give you 30 for that side right there. So that's another thing you know, is that's a 30-degree angle in here. So we're trying to find out what y degrees is. How many degrees is this base angle down here? You could start off by saying, well, we know that they all have to add up to 180. And that's one reason why I've been playing that video, to just remind you that the angles in a triangle all have to add up to 180. You need to constantly remember that and use that throughout this entire chapter, and anytime we're dealing with triangles. Angles all add up to 180 in a triangle. And so we can say is that 180 minus 30 would tell us how much these two are together. So we could start there. 180 minus 30 would give us 150. And since there are two of them, but they're exactly the same, we can then divide that by 2. So divide 150 by 2, we get 75. That tells us that each of these angles is 75 degrees. So now we know what y is. Y is 75. And so if we know that that's 75 degrees right there, we can now have a y here and know that that's 75. 75 minus 25 will give us what this side is here. And that side is going to be the same as the x side over here, because that we are also concluded that that's the same as this one, which is the same as all three of these on this triangle. So you find this side, you will find out what x equals. So we can just plug that in. 75 minus 25 is 50, so we can conclude that x equals 50. All right, coming over here to this triangle, another thing we can see here, so I left these there, I shouldn't have, but that's okay. One thing you can realize here right off the bat is you have an equilateral triangle at the bottom, and I already marked these off here because we could see on this triangle we have an equal, or these two sides are equal, telling us that this is an isosceles triangle at the top. And if it is isosceles, we know the base angles are going to be congruent. These are the same measure at the bottom for the base angle. That's why I marked these off here to show that those are the same. So we could start off by figuring out what does x equal here, because we can do it the same way as we did this one. We know that this is 40 up here, and all the angles inside here add up to 180. So we can start with just doing 180 minus 40. So 180 minus the 40 degrees will give us 140 for the two of these together. But since they're both exactly the same, we can divide 140 by 2 and figure out that each one separately is 70 degrees. So this is 70 and this is 70, so x is 70. That's what we can conclude. X has got to be 70. And then down here we see an x minus a y, so we can plug in 70 right there. So that would be 70 minus y here for this side. And so now what we have is that these two sides are exactly the same. In fact, all of them are exactly the same. But if this is congruent to this one and they both have a y in them, we can set these equal to each other to solve an equation. So we can set up our equation like this. 2y plus 10 for this one is equal to 70 minus y here, and then just solve the equation for y. And so we'll start by first adding y to both sides, getting 3y plus 10 is equal to 70, and then subtract 10 from both sides to get 3y equal to 60, and then just divide by 3, and 60 divided by 3 would give us 20. So there you go, with y is equal to 20. All right, so that concludes our lesson here on 5.4, and should be ready now to get into the 5.4 assignment. I'll see you guys later.